Quadratic equations can be solved in multiple ways. You could solve quadratic equations by graphing it. You could solve it by factoring it. In this video, we're going to solve how you can complete the square. But before we go through completing the square, I first want to go through how you can use the square root property. So, first example says solve x squared minus 4x plus 4 equaling 25 using the square root property. Now the first thing we want to do is see if on our left side, so this x squared minus 4x plus 4, we want to see if this is a perfect square trinomial. So here, if I have x squared minus 4x plus 4, I gotta think, what do you want to multiply to get 4, but add them together gives me negative 4? Well, I know that I could do x minus 2 times x minus 2 would give me a perfect square trinomial, because negative 2 times negative 2 is 4, but negative 2 plus negative 2 is a negative 4. So when I have a perfect square trinomial, I can write it as a binomial squared. And the binomial squared in this example would be x minus 2 squared. So x squared minus 4x plus 4 is the same as saying x minus 2 squared. Now this is going to equal our 25 that we have on the right hand side. Once we've factored the trinomial on the left, now all we have to do is solve for x by undoing the square. When you undo a square, you find the square root of both sides. So that's going to give me an x minus 2, because the radical undoes the exponents. They are inverses of each other. That's going to give us the square root of 25 is a positive 5 and a negative 5. Remember, when you find a square root of a number, you have a positive and a negative root. Now our last step is just to get x by itself. So right now I'm subtracting 2. I'm going to be adding 2 to both sides, and I'm just going to do it to both these numbers so I can find both of my solutions. So in this example, x is going to equal 5 plus 2 is 7, and negative 5 plus 2 is a negative 3. So my two solutions in this example would be 7 and negative 3. Second example, x squared plus 24x plus 144 equals 192. But you'll notice in the heading, these are irrational roots. That means these are numbers that do not, there are going to be decimals that do not end and they do not repeat. So let's solve this one. Again, on the left side, we are going to have a perfect square trinomial. And a quick way of doing this is just make sure this first term is a perfect square and the third term is a perfect square. And if you take the square roots of both of them, the square root of x squared is x, the square root of 144 is 12. You just want to make sure that that number is half of this middle number. And then we're going to use the same sign that they have here. So this will be x plus 12. So x plus 12 squared. This is going to equal 192. Now to undo a square, we find the square root of both sides. And now I'm left with x plus 12 equals 192. Now 192 is not a perfect square. So there's a couple ways you can do this. You could find the exact answer, or you could find an abbreviated answer or an estimated answer. So I'll show you how to do both. So if we're going to do the exact answer, for 192, the square root of 192, I could break that down. Let's get my calculator out. If we take 192, and let's just say we divide that by 4. That gives us 48. Let's see if we can do another perfect square. 192 divided by 16. That would give us 12. So I could break this down as the square root of 16 times the square root of 12. And I can break down the square root of 12 as the square root of 4 and the square root of 3. I already know that the square root of 16 is 4. So I know this is 4. This is 2. So now I have 4 times 2, which is 8, times the square root of 3. So this is a positive and negative 8 square root of 3. All I have to do to get x by itself is subtract 12. And I would have x equaling a negative 12 plus or minus 8 square root of 3. That would be the exact answer. Now, if I weren't going to find the exact, if I was just going to do an estimated answer, I would have your x plus 12 equals, and we're going to do the square root of 192. So if we grab our calculator again, and we're going to do the square roots of 192. That would give us 13.856. I'm going to round it to the nearest hundredth, so 13.86. So this is going to be a positive and a negative 13.86. Now to get x by itself, I'm going to subtract 12. And I would have x equaling about, and let's get our calculator again. We have a negative 12 minus 13.86 which will give us an answer of negative 25.86. And it would also equal if I had negative 12 plus 13.86. And that would give us 1.86. So these would be estimated, these would be the exact. And our final example. Here we're going to have complex solutions. That means we are going to have part of the answer is real and the other part is going to be imaginary. So here we have 2x squared minus 92x plus 1058 equaling a negative 36. Now the first thing I want to do is I want to make sure this is just a plain 1x squared. So to do that, I'm going to divide everything by 2. When I do that on both sides, I'm just reducing, it has the same value, but I'm just reducing the whole equation so I have smaller numbers. So this is going to give us an x squared minus 92 divided by 2. Well, if I did 90 in half, that would be 45. So it has to be, this would be 46. So 46x plus half of 1058 would give us 529 equals a negative 36. Next, we have a perfect square trinomial here. So this is going to be x minus, and the square root of 529, or think of half of 46 would be 23. This is squared, because that's what this trinomial would be factored, equaling a negative 36. Now to undo a square, we're going to find the square root of both sides. And this is going to give us x minus 23 equaling a positive and negative. And here I have a negative inside the radical. That means this is like saying the square root of negative 1 times the square root of 36. And the square root of negative 1 is an imaginary number. It's noted as I. And then the square root of 36 is 6. So what I have here is x minus 23 equals a positive and negative 6i. And to get x by itself, I'm going to add 23 to both sides. So my final answer would be x equaling 23 plus or minus 6i. Now I cannot combine these because they're not like terms. One's an imaginary number and the other one's real. So that is how you can solve quadratic equations by using the square root function, or the square root property.